Okay, so just to give you some context on like what we are doing here. The last two classes, really, because it kind of took us 2 lessons there. We were talking about Taylor series and Maclaurin series expansions, and those work for particular types of equations. We now know the e to the x1, the sine of x1, the cosine of x1. A lot of those that are not equations that follow particular patterns are great for Taylor and Maclaurin series. Okay, and we have our formulas for that. We're also kind of going to build some other ways to build out some of these power series that we're talking about. And one of them is to recognize things as geometric series. So we're going to do a little review of geometric so that you kind of understand where we're going with this. And geometric, we didn't love so much when we did those on the quiz either. So this is a good review. So remember, geometric series all follow a particular pattern. They're all formed by multiplying by a common ratio r. So if we started with a sub 1 equals 2 and we let r equals 3, what would our geometric series look like? We would start with 2, and then it would be plus what? How do you find the next term using r? R is your multiplier in a geometric series. So every term then after the first gets multiplied by that common r. So my next term, if my first term is 2, would be what? 6. Then 18. Then 54, dot, dot, dot. Okay, we're not going to keep going out endlessly on that. So the question is then, how do you write a general term for this? Well, we know what a geometric series looks like, right? From our formulas. So we say dot, dot, dot plus, here's our summation. N equals, where does geometric start at? 0. Okay, geometric always starts at 0. Remember that from our sums. How do you write a geometric series general term? A sub 1 goes out front, that's 2. Times r to the n. And that is why it starts with n equals 0, because that common ratio r does not apply till the second term when n equals 1. We okay with that? How would it change if a sub 1 equaled 2 and r equals negative 3? Same numbers, but what would happen to the series? Alternating. Yes? So a sub 1 is 2. My second term would be negative 6, and then 18, and then negative 54 plus dot, dot, dot. Plus, how would my general term change? 2 times negative 3 to the n. You could separate it out as a negative 1 and keep the 3, but in geometric, we generally leave it in with the r. Now, we're really going to throw this into kind of a different thought process. But if a sub 1 equaled 1 and r equals x, what would that look like? 1 plus x squared plus x cubed plus dot, dot, dot. Now let's think about how to write our general term.
X to the
N equals 0. 1 goes out front. X to the nth power. Do I really need to write the 1? No, but just kind of keep in mind your a sub 1 goes out front. Yes? All right. Now, what I also want you to keep in mind is that this summation is the sum of all the terms in a geometric series, yes? Did we have another way of writing the sum of a geometric series? S equals A over 1 minus R. So another way of recognizing something that would work as a geometric series is seeing the summation written as a function. So you could see a function written as 1 over 1 minus x. How does that work for that summation? Well, we just said the sum, this is one way of writing the sum. Another way of writing the sum is this. What's the a in this series? 1 over 1 minus r. What was my r? X. So what this tells us is that if we are given equations that we can manipulate to be in this kind of format, we can use geometric series to write out their terms a little bit more easily. So it's seeing a pattern and using it to quickly write the series without taking nasty derivatives again. Yes?
How does that work since x is a variable? Like, would it not diverge?
Because x, yeah, so it would most likely diverge, but we're not even really talking about whether it converges or diverges. We're just writing out. It has, you can find the sum kind of as a limit. You're looking as it approaches infinity and continuing to add up. Yes, it diverges, so it's infinite, but yeah. We're not actually finding the value of it. So when we're writing power series, we're not actually writing the value of it. We are writing a series that approximates that sum if you find all the different terms. So the approximation is the real key to it because it's not going to be exact because you're right, it does diverge. I feel like that didn't actually answer your question.
It's all good. As long as you're writing that. JB prefers to be on that side. I actually like to just have no idea. I don't know the general thing.
So I could totally take f of x here and build it out as a Taylor or Maclaurin series. But what would I have to do that? Take lots of derivatives. A lot of times with these kind of fraction ones, the derivatives are not super nice. And that's kind of where we got into last time, knowing the e to the x, knowing the sine x, knowing the cosine x. I could then do the sine of x squared a whole lot easier than taking all the derivatives of sine of x squared. Same thing here. If I don't want to walk through all the derivatives of this f of x because it wouldn't be super nice, what kind of rules would I have to use to take the derivatives here? Either multiple quotient rules or multiple chain rules. And once you did the first one, it would get even uglier because the derivative of the inside is negative 2x, right? So do we all agree the derivatives there would be super nasty? Yeah. Yes. So what this is saying, if I'd rather not use the other skills we just learned with the Taylor and Maclaurin series, and this obviously is not one that we can do from last class because it's not a type of e to the x or sine x or cosine x. There is another way of thinking about it. It's kind of another shortcut for it. So knowing that this equation in some ways is similar to the geometric sum, it allows me to write it using what I know about geometric series rather than taking a bunch of derivatives. Does that kind of help, like, put us in context of where we're at? Because I don't want to take the derivatives. So what we are doing then is we're shortcutting. Okay, we're shortcutting. So if I would like to shortcut this, I need to think about that equation in the form of that sum formula. So if I think about, does it fit right now, the sum formula? Yeah, really nicely. It has an a value on top, that's 1. It has a 1 minus an r. It doesn't even have to be a minus r because the r can be negative, right? So if I just kind of took that and compared it to that, I would say to myself, well, because it fits the geometric, I know that a is 1. And I know that r is what? X squared, right?
You just write it as x.
So rather than taking a bunch of derivatives and dealing with that Taylor or Maclaurin series polynomial, I can just say, well, I know this is a geometric. So the first term would be 1. The second term would be
X squared.
x squared. The third term would be
X to the fourth.
x to the fourth. It says the first four non-zero terms, so I need one more, x to the sixth plus ... and then write my general term. The general term of this would also fit a geometric, where we can write it as the a out front times x squared to the n power. Isn't that a whole lot easier than taking all of the derivatives of 1 over 1 minus x squared and plugging them in with factorials and reducing and all of that? It's a shortcut to doing it because I can recognize it as a geometric. Okay? Now, they're not all going to be set up very super nice for geometric. Sometimes it comes with a little bit of manipulation. So look at the second one here. This doesn't quite fit what a geometric looks like. What's the main issue on that one? The 4 in place of the 1. So really what you have to do when you're manipulating is make sure you see a 1 minus r on the bottom. So if I want that to be a 1, what's the easiest way to make it a 1? Factor out the 4. So if I manipulate this, I can write it as 1 over, we all know how to pull a 4 out of that. That would leave me a 1. Now think about what that makes your x. X over 4. Because really isn't factoring just division. Now, the geometric sum formula doesn't have a 4 hanging out in front or any number hanging out in front. So how else could I write it? I can pull the 1/4 to the top. So I can think about the 1/4 as up here and leave it as 1 plus x over 4 on bottom. Now that feels a little bit weird, but does that make it fit the geometric? Yes. So now the way it's written, what is my a, or my a sub 1? 1/4. What is my r? Negative 1/4 x, or negative x over 4. However you want to write that. So now that it's in that format, let's write it as a geometric power series, starting with our a sub 1, which is 1/4. What would the next term look like? Negative x over 16. Now, as you start to multiply out, we want it to be the first 4 non-zero terms. What's going to multiply on the bottom every time? 4. So if you don't want to multiply out the bottom, because it's about to get big numbers pretty fast, couldn't I just write that as 4 squared? Okay, so then the next term would look like plus x what? Squared over 64, or 4 cubed. You're more than welcome to multiply it out, but it's okay to do this. And then it becomes minus, x cubed over 256, or 4 to the 4th, plus ... Let's write our general term. How do we write our general term? A out front, negative x over 4 to the n. You could, yeah. They'll take alternate versions of that. I'm always going to go for the most straightforward. I really like just plugging the numbers in where they go and not really simplifying. All right, now, in general, just because I want to make sure you have good context for this, there might be a couple questions like number 1, the first one. Most of these, as far as it would go, is probably the manipulation we see in the second. It is not out of the realm of possibility that you would have to do the manipulation that you see in 3, but it's less common. So we're going to walk through it, and we're going to see it because y'all are smart enough to do it. It's just not as common, so understand that, okay? What's the big differences in this third one?
It's just the
Yeah, the bottom's all funky. There's one other big difference. It's centered at x equals 2. Okay, so if the center is something different than 0, that means in that summation formula that we were looking at, the summation formula we said was a over 1 minus r. And when we made it kind of a general one, we said it was like very similar to 1 over 1 minus x, right? That's what we said on that first one. Those are all centered at 0 because there's just an x in there. So what you're going to have to see if it's centered at 2 is an x minus 2 in there. You're going to need to manipulate it to see that. Now, the best way to do this is to kind of start making the equation they give you into what you want it to be, and then just kind of fix the issues with it, okay? So when I start manipulating the f of x, the first thing I think about is just switching these, because that puts the number and the x in the right spot, right? And that 2 is attached to the x. I need it to be there. So if I needed to say an x minus 2 in there, let's just start with that, okay? So I'm going to write my f of x, and I'm going to start by just leaving the 15 alone because I'm not messing with that. And I'm going to write it as 2 times x minus 2 right there, okay? Now I know I've left out this minus 1, but we're going to work with that out here and make it kind of something else in a minute. I need to kind of force that x to be an x minus 2 so that I can make the center x minus 2. Are we okay with that? If I distribute that 2 in, what is that really? A 2x minus 4. So if I have a 2x minus 4 and I have that minus 1 out front, what number needs to be right there? A 3. Why does that work? Yeah, because if I actually multiplied that out, that would say 3 plus 2x minus 4. Does that simplify to be exactly that? Yeah. It does. It's like the quadratic equation. Yeah, it's kind of like the completing the square stuff where we had to like make it match and balance it. It's very similar to that. So you ask yourself, what number do I need out front there to make it equivalent to what I had originally? Now we're kind of back to where we were on this previous question because that's still not the 1 I need out front. Yes? So what did we do with it in the previous question when it was a 4? We factored out the 4, right? So my next step in manipulation would be to factor out that 3. If I take the 3 out, it will leave me a 1 there. What's the best way to write that back part?
2/5.
Yeah, just a 2 over 3?
Oh, 3, sorry.
Yeah? So that's a 2/3 x minus 2. Yeah? Now, remember what we did on the previous one with the 4 down there? What did we do with it?
Just put it up top.
We brought it up top. So if I bring the 3 up top underneath the 15, what's that going to really make this? 5 over 1 plus 2/3 times x minus 2. Does that now fit our geometric?
That's a lot of work.
It is. It is a lot of work. But also think about the derivatives of that. That would also be a lot of work. And probably more. So in this format, what's my A?
5.
5. What's my R?
2/3 x minus 2.
Negative 2/3 x minus 2. Yeah? Watch the negatives. Okay? Not trying to be a gotcha on that one. But,
How it is, Miss Lanigan.
so how would I write? Start with what?
I always knew you hated me.
Oh, yes, you got me. Where do I start? What's my first term?
5.
5.
I did it.
And then the next term would look like what?
Negative, my
5 would be multiplied by the R.
negative 10 over 3.
Negative 10 over 3, x minus 2.
That's horrible. Why would you do that to us?
What's the next one? 20 over
4, 6, 9.
9. X minus 2 to the second. Third term. Minus 40 over 27. X minus 2 to the third. Plus 80 over...
81.
No, did I do 4 non-zero terms? 1, 2, 3, 4. Okay, I'm good there. I don't need to do the 80. All right, stop before you go to the 80. Plus, dot, dot, dot. How do I write this as a sum, a general term?
5 times
5,
times
negative 2/3 x minus 2, all raised to the n. I am not simplifying those terms. Okay? This is a free response. You don't need to do it. Yeah.
Is the n start at 2, or is it the x is 2?
The x is centered at 2.
Always honest with my nigger. I only get half this unit.
Geometric are always that.
I only get half this unit.
Yeah.
Yeah, I don't get it either.